In this module, we shall discuss the fiscal shocks. Fiscal policy is the instrument by which the government of a country adjusts its spending levels, that is its expenditure, and its income, that is tax revenues or tax rates, to monitor and influence the country's economy. It is the sister strategy to the monetary policy through which a central bank influences a nation's money supply. The major instruments of fiscal policy are budget, taxation, public works, public expenditure, and public debt. Fiscal policy can have two forms: a fiscal expansion or a fiscal contraction. A fiscal expansion is generally defined as an increase in economic spending owing to actions taken by the government, for example, in the form of tax cuts, rebates, and increased government spending, whereas a fiscal contraction would be its opposite, in which there would be a decrease in the economic spending due to the actions of the government, like increase in taxes or reduction in government expenditure. A fiscal shock is that activity of the government of a country that results in the shift in the IS curve. This shock can be positive, which lead to the rightward shift in IS curve, and it could be negative as well, which will lead to a leftward shift in the IS curve. After studying this module, you shall be able to understand what is meant by fiscal policy and fiscal shocks, know about the effect of a fiscal shock on interest rate, output, and price level in the short run, medium run, and long run, understand the adjustment path, understand the similarities and differences between the effect of a monetary and a fiscal shock. First, we shall discuss the effects of a fiscal shock in the short and medium run. This is also known as the adjustment path. Let us take the case of a negative fiscal shock. The fiscal contraction is assumed to happen due to a decrease in the government spending. Before the change in the government spending, the aggregate demand in the economy is represented by the AD curve. The aggregate supply is represented by the AS curve. Aggregate demand and aggregate supply curve intersect at point A, at which the equilibrium output is Yn, which is the natural level of output, and the price level is given by P, which is equal to the expected price level. Now, the government decides to decrease its spending, that is G. Aggregate demand equation is given by Y is equals to Y bracket M by P comma G comma T, where G stands for government expenditure or spending, and T stands for the taxes, and M by P stands for the real money stock. Now, from the equation, it can be seen that a decrease in government spending would reduce the output in the short run. The aggregate demand curve shifts to the left from AD to AD dash. For a given level of price, output is lower. In the short run, the equilibrium moves from A to A dash, output decreases from Yn to Y dash, and the price level decreases from P to P dash, and interest rate also decreases. Here, in the short run, we cannot tell whether or not investment decreases or increases. This is because lower output decreases investments, but lower interest rate increases investments. Over time, the adjustment of price expectations comes into play. Aggregate supply curve, which is given by the equation P is equals to P to the power E into 1 plus mu into F into 1 minus Y by L, comma Z, where PE is the expected price level, mu is the markup, Z is the catch-all variable for all other factors that affect wage determination and in turn prices, L is the labor force, shifts right. This happens because the output in the short run is less than the natural level of output. The price level is lower than what the wage setters expected. They therefore revise their expectations, which cause the aggregate supply curve to shift right. The economy moves down the new aggregate demand curve, that is AD dash. The adjustment process continues till the output returns to the natural rate of output. The final equilibrium happens at the intersection of the AS curve, represented by AS double dash, and the AD dash curve at point A double dash, where the output is the same as Yn and the price lever is at P double dash. Note that P double dash is lower than both B and P dash. Here in the medium run, we can tell the effect of a decreased government spending on investment level. This can be understood with the help of the IS curve equation, which is given by the following expression. Yn is equals to C into Yn minus T plus I into Yn comma I plus G. In the medium run, output is same as before. As output and tax rates are unchanged, therefore the consumption is also the same as before. Now with reduced government spending, to maintain the equation, investment has to increase by the same level as the decrease in the government spending. Put another way, in the medium run, a reduction in government spending unambiguously leads to a decrease in the interest rate and an increase in investment. The discussion shows that in the short run, a negative fiscal shock or fiscal contraction leads to a decrease in the output, a decrease in the interest rate, and a decrease in the price level. But over time, the effect of the negative fiscal shock on output disappears and the interest rate and the price level decreases further. Similarities and differences in the effects of monetary and fiscal shocks. In the short run, both the types of shocks affect all the three variables, namely price level, interest rate and output. Like a monetary shock, for example, an increase in the nominal money supply, a fiscal shock, for example, a reduction in the government spending, also does not affect the output forever and eventually the output returns to its natural level of output in both the cases in the medium run. But there is an important difference between the effects of these two shocks on the interest rate in the medium run. While the interest rate comes back to its original level in case of a monetary shock, this is not the case with the fiscal shock. Moving on to the long run equilibrium. The output in the long run depends upon two relations between output and capital. First, The amount of capital determines the amount of output being produced. Second, the amount of output determines the amount of savings and in turn the amount of capital being accumulated over time. The first relation, output per worker, is a function of capital per worker under assumption of constant population size, constant participation and unemployment rate and a situation of no technological progress can be written as Yt by n is equals to F Kt by n. This is equation 1. The second relation can be explained in two steps. Step 1. Deriving the relation between output and investment. This relation is derived under three assumptions. The economy is closed, which implies investment is equal to the sum of private and public savings, that is T minus G, that is I is equals to S plus T minus G. Second assumption is that public savings are 0 so that we can focus on the behavior of the private savings. And the last one is that private savings is proportional to income, that is S is equals to small s into y, where small s is the saving rate. Combining all these three assumptions, we can write the following equation. I is equals to S is equals to small s into y, or It is equals to small s into Yt. This is equation 2. That is, investment is proportional to output. Step 2. Deriving the relation between investment and capital accumulation. Assume that capital depreciates at the rate of lambda per year, then the evolution of capital stock from year t to t plus 1 can be written as Kt plus 1 by n is equals to 1 minus lambda bracket Kt by n plus It by n. That is, capital per worker at the beginning of year t plus 1 is equals to the capital per worker at the beginning of year t adjusted for depreciation plus investment per worker during the year t. By expanding and rearranging the terms in equation 3, we get Kt plus 1 by n minus Kt by n is equals to It by n minus lambda Kt by n. And if we put the value of investment from equation 2 to equation 4, we get Kt plus 1 by n minus Kt by n is equals to small syt by n minus lambda into Kt by n. This is equation 5. That is, change in capital stock per worker is the difference between savings per worker and depreciation per worker. Dynamics of capital and output. By putting the value of output per worker from equation 1 in equation 5, we get Kt plus 1 by n minus Kt by n is equals to small s into f Kt by n minus lambda Kt by n. This is equation 6. If investment per worker exceeds depreciation per worker, capital per worker increases, and when investment per worker is less than the depreciation per worker, the capital per worker decreases. It is only when investment per worker is equals to the depreciation per worker that the capital per worker remains unchanged and thereby the output per worker remains unchanged. These levels of capital per worker and output per worker are the long run equilibrium levels and are given by K star by n and Y star by n respectively. Thus, it can be said that in the long run, growth in output per worker is 0 because the output is not changing as the capital is not changing. Steady state capital and output. The state in which output per worker and capital per worker are no longer changing is called the steady state of the economy. Putting the left side of equation 6 is equals to 0, that is change in capital as 0, we get the value of steady state capital as S into F K star T by N is equals to lambda K star T by N. That is, steady state value of capital per worker is such that the amount of savings per worker is just sufficient to cover depreciation of capital stock per worker. The savings rate and output. So, answering the question, how savings affect the growth of output per worker? First, the savings rate has no effect on the long run growth rate of output per worker, which is equals to 0. This is because in the long run, economy converges to a constant level of output per worker. Second, but the savings rate does determine the level of output per worker in the long run. The countries that have a higher savings rate achieve a higher output per worker in the long run. Thus, an increase in saving rate will lead to higher output per worker for some time but not forever. The fiscal policy is an important instrument in the hands of the government of a country to regulate the economy. Through its fiscal policy, it can affect the aggregate demand, interest rates, and output and price levels in the economy. The fiscal shocks affect the output, interest rate, and the price level in the short run, while in the medium run, they affect only the price level and interest rates, keeping the output as before at the natural level of employment. Let us now summarize what we have learnt in this module. The government of a country, through the various instruments of fiscal policy, affects the level of aggregate demand and other variables which depend on the level of aggregate demand. The contractionary fiscal policy or a negative fiscal shock results in decreasing the aggregate demand, while an expansionary fiscal policy or a positive fiscal shock results in increasing the aggregate demand. In the short run, a fiscal shock affects the output, price level, and the interest rates. For example, a negative fiscal shock led to a decrease in interest rates, output, and the price level in the short run. In the medium run, a fiscal shock affects only the price level and interest rate, keeping the output unaffected at the natural rate of employment. In case of a negative fiscal shock, the decrease in government spending led to only a decrease in the price level and the interest rate, keeping the output unaffected in the medium run. The effect of a decreased government spending on investment cannot be told with certainty in the short run, but in the medium run, it increases investments by an equivalent amount. There are some similarities and some differences in the effects of a monetary and a fiscal shock. While both these shocks affect output, interest rates, and price levels of an economy in the short run, their effects in the medium and the long run are different. While the monetary shock affects only the price level, the fiscal shock affects both the price level and the interest rate in the medium run. The fiscal policy is affected in improving the health of an economy, but its effect on output cannot be sustained forever.